I'm going to take a look at number 5 from section 6.4. The owner of a motel has 50 rooms to rent. She finds that if she charges $25 per room per night, all the rooms will be rented. For every $5 that she increases the price of a room, 2 rooms will stand vacant. And to complete the table below, we're going to start with the base price of $25 and fill in the column for price based on how many price increases that there were, and then the number of rooms rented. And so the price of $25, all rooms would be rented, which is 50 rooms. And to get the total revenue, we're just going to multiply those two values together. And we get 1250. Okay, same thing for if we have one price increase, the price would be $30. The number of rooms rented is 48 because that would decrease by 2. And then if you multiply those together, we get 1440. And so to continue filling in the table, if we had 2 price increases, the price of the room would be $35. And then the number of rooms rented, that would still decrease by 2, so 46. And if we multiply that together, we get 1610. Okay, and then you can continue completing the table in this manner. Okay, let X stand for the number of $5 price increases that the owner makes. We want to write an algebraic expression for the price of a room, the number of rooms that will be rented, and the total revenue earned at that price. And so the price of a room, again, it started at $25. It increased and by $5 every time, and so plus 5x would give us the total price of the room. And then the number of rooms rented, well, that started with 50 rooms, but that was decreasing every time there was a price increase, and it decreased by 2 every time, and so that's going to be minus 2x. And the total revenue is found by just taking the product. It's the price of a room, 25 plus 5x, and then times the number of rooms rented, 50 minus 2x. Okay, so now we're going to use our calculator to graph the function and figure out the lowest price that the owner could charge for a room if she wants her revenue to exceed $1,760 per night. Okay, so in Y1, I've plotted this function. Okay, I then found a decent window. I hit zoom 6 and then zoom fit. And then adjusted my X max sum to see more of the graph. Okay, but in Y2, we're going to put this revenue that's wanted, so the 1760. Okay, and there are 2 times where that could happen. So if we find the intersection of those graphs, okay, we first see that that happens after 3x equals 3, or 3 price increases. And then we do that again, use the intersect feature, and scroll to the other side of the vertex to then hit enter 3 times. Okay, and that is 17 after 17 price increases. Okay, so we take our formula for the price of a room, which is 25 plus 5x, and then we can use that to determine what the actual price of the room would be. And so the first one, we would have 25 plus 5 times 3 for 3 price increases, or 25 plus 15, which is $40. Okay, the other option is the highest price that she could charge was after 17 increases. So 25 plus 5 times 17 is 25 plus 85, or $110. Okay, and then the next part, it asks what is the maximum revenue the owner could earn in one night. So we're going to go back to the graph. I'm going to delete Y2. We no longer need that line. And then try to find the maximum value of this function. Okay, so under second trace, the maximum feature is number 4. We need to just have our cursor somewhere to the left of the vertex and then scroll to the right of the vertex and hit enter, and then hit enter one more time, and we see that the maximum revenue, that's the Y value, is $22.50. Okay, and then it says how much should she charge for a room to maximize her revenue. So if you go back and notice when that occurred, that was when X is 10. So using the formula for the price of a room, one more time, we have 25 plus 5 times 10, or 25 plus 50, which is $75. And then how many rooms will she rent at that price? Okay, again, remember that X is 10, but notice the number of rooms. The formula for that was 50 minus 2x. So this will be 50 minus 2 times 10, or 50 minus 20, so 30 rooms at that price.